Orcas kill great white sharks. They kill blue whales, the largest animals that have ever existed on this planet, bigger than any dinosaur. They flip sharks upside down and eat only the liver, with the precision of a surgeon. And once a shark population learns that an orcapod has moved into its hunting grounds, the sharks simply leave, sometimes for the better part of a year, abandoning territory they'd occupied for generations rather than risk another encounter. There is functionally nothing in the ocean an orcapod cannot bring down if it decides to, except one thing: a slow, lumpy, oddly shaped animal that is, on average, smaller than the blue whales orcas already kill on a regular basis. If size were the deciding factor here, this shouldn't even be a conversation. But it is, because the numbers don't add up the way you'd expect. And once you see why, you'll never look at either of these animals the same way again. Understanding just how selective orcas are about this one species requires seeing briefly exactly how unselective they are about almost everything else. Great white sharks, an animal most people would confidently call the ocean's apex predator in its own right, are not simply occasionally preyed upon by orcas. They are, in specific documented regions, systematically driven out. Off the coast of South Africa, marine biologists spent years puzzled by a sudden, dramatic decline in the local great white population. Sharks that had reliably gathered at known feeding grounds for as long as researchers had been tracking them simply stopped showing up. Carcasses that did wash ashore were missing one specific organ, the liver, extracted with a precision that ruled out a random scavenging event. The explanation, once identified, turned out to be a small number of individual orcas, in some cases as few as 2 working together, that had begun specifically targeting great whites in that region, striking with enough speed and force to flip and disable a shark that can itself grow to over 15 feet long, before extracting the single most calorie-dense organ in its body and leaving the rest. Once local great whites detected that even a couple of these orcas were active nearby, the entire regional shark population relocated en masse and stayed away for extended periods afterward. A level of fear response that a species widely regarded as untouchable simply doesn't show toward anything else in its environment. If that is the caliber of predator orcas are willing to identify, target, and specialize in hunting, sometimes with a pod of only 2 individuals, then their consistent avoidance of adult sperm whales starts to look less like a puzzling exception and more like a very deliberate, very specific line orcas have drawn based on direct experience with what that particular animal can do in return. Let's deal with the size argument immediately, because it's the first thing everyone assumes. And it's also almost completely wrong. An adult female sperm whale runs somewhere between 40 and 50 feet long, weighing in the range of 30 to 50 tons depending on age and condition. An orca, by comparison, weighs somewhere around 6 to 9 tons. So on paper, yes, a sperm whale outweighs an orca by a wide margin, roughly 5 or 6 times over. That looks like your answer right there. Bigger animal, more caution. Except a blue whale weighs up to 200 tons or more, 4 times heavier than even the largest sperm whale, nearly double the length. And orcapods hunt those. Documented, repeated, filmed. If a 200-ton blue whale isn't safe from a coordinated orcapod, a 50-ton sperm whale should, by any reasonable weight-based logic, be comfortably within reach. So weight class isn't actually protecting the sperm whale. Something else is going on, and it has almost nothing to do with mass and everything to do with what each animal does in the 90 seconds after an orcapod shows up. Here's the blue whale's entire strategy, from start to finish: run. That's it. That's the whole plan. Blue whales are baleen whales, filter feeders, built with a long hydrodynamic body optimized for cutting through water in a straight line at speed, up to around 30 miles an hour in short bursts. They have no teeth. Their skulls are thin and flexible, built for engulfing enormous volumes of water and krill, not for combat of any kind. A blue whale under attack has one option: which is to try and outlast the orcas on raw endurance, hoping the pod eventually gives up and moves on to easier prey. It's a gamble on stamina, nothing more. And orcas have figured out exactly how to beat that gamble. They don't chase in one continuous sprint, because they lose that race eventually too. Instead, they run relays. One group harasses the whale, forcing it to keep expending energy, while a second group hangs back and conserves its own. They rotate. They also physically climb onto the whale's back and ram its sides, not just to injure it, but to add drag, forcing the whale to burn even more oxygen and calories just to hold its speed. Hour after hour, the exhaustion compounds. Eventually, the blue whale can no longer maintain the pace, and once it's spent, the pod does something specific and almost clinical. They physically block it from surfacing, taking turns pushing its body underwater until it can no longer breathe. The largest animal in the history of life on Earth typically doesn't die from blood loss in these encounters. It drowns because it was built entirely for one strategy, and that strategy has a known exploitable weakness. A sperm whale, confronted with the exact same pod of orcas, does not do this at all. And that single difference in behavior is the actual answer to the entire question, more than any measurement of size or weight ever could be. Sperm whales are slow, genuinely slow. Their cruising speed sits around 4 to 5 miles an hour, and even flat out in a sprint, they cannot get anywhere near an orca's top speed. If a sperm whale tried to run the same relay race gambit a blue whale runs, it would lose, decisively, every single time, and it would burn itself out doing it. So somewhere in their evolutionary history, sperm whales stop trying. They don't run. When a pod of orcas shows up, an adult sperm whale, particularly a group of them, does the single most disruptive thing it can do to a predator whose entire hunting strategy depends on pursuit. It stops moving and turns to face the threat. Think about what that actually does to an orcapod's calculus. Every hunting strategy we just described for the blue whale depends on chasing something that's trying to get away. Take away the chase, and the entire playbook collapses. You cannot run a war of attrition against an opponent who refuses to move, who isn't burning any extra energy fleeing, and who is, instead, actively facing you down. For an orca, every single hunt is fundamentally an economic transaction. Calories spent against calories gained, injury risk weighed against caloric reward. A prey animal that stands its ground and can genuinely hurt you back flips that transaction from a safe bet into a gamble nobody sensible takes unless they're desperate. And a sperm whale can genuinely hurt an orca. This is where the anatomy gets strange, and where you start to understand why evolution built this animal the way it did. Look at a sperm whale's proportions, and something looks immediately wrong. A full third of the animal's entire body length is just head. Not brain, mostly, even though sperm whales do carry the largest brain of any animal that has ever lived on Earth, larger even than any whale species besides themselves. That brain, remarkable as it is, only accounts for a small fraction of the space inside that skull. The rest of it is taken up by something called the Spermaceti organ, a structure containing several hundred gallons of a specialized waxy oil, which is, incidentally, exactly where the species gets its unfortunate common name from, thanks to 18th century whalers who mistook the substance for something else entirely. For decades, the leading theory among researchers was that this organ served a genuinely startling secondary function, beyond its more mundane, better supported roles in echolocation and buoyancy control. The idea was that a sperm whale could regulate blood flow around this oil-filled structure, and, in doing so, actually shift the oil's temperature and, with it, its density and rigidity. Cool it. And the oil could theoretically stiffen, turning that entire enormous dense forward section of the skull into something closer to a solid mass than a soft one, an on-demand biological battering ram. It's worth being honest here that this specific cooling into a weapon mechanism remains debated among researchers, and the organ's primary confirmed jobs are focused around sound production and buoyancy. But what isn't in dispute is the structural reality of the thing itself. Dense, heavy, positioned at the front of an enormous animal, and backed by tens of tons of forward momentum. We don't have to speculate about what that structure is capable of in a worst case scenario, because history already gave us a documented, verified example. In 1820, the whaling ship Essex, roughly 90 feet of solid oak construction, was struck head on, twice, by an angry bull sperm whale in the Pacific. 2 direct hits from that animal's head were enough to stave in the ship's hull and sink it outright. An event so well documented by surviving crew members that it went on to directly inspire Moby Dick. Run the physics on that kind of impact. A whale of that mass, moving at speed, delivers kinetic energy on collision that a wooden hull, built to withstand ocean storms, simply could not absorb. Now put an orca in that ship's position instead of solid oak. An orca is flesh, blood, and bone. A direct head-on strike from a sperm whale carries more than enough force to break ribs, rupture organs, or kill outright. That is not a small risk to gamble a hunt on. And orcas, whatever else you want to say about them, are not reckless animals. They are, by every account we have, some of the most calculating predators in the ocean. So ramming exists as a real, demonstrated possibility, a threat orcas have to factor in, even though outright head-on collisions are actually rare in observed encounters. Mostly because a sperm whale coming at full speed is visible from a long way off, and a sensible orca pod isn't going to sit still and wait to find out how hard that hit lands. The head is the deterrent that keeps them at a distance. What actually happens at closer range, especially when calves are involved, is something more organized and considerably harder to break through. Sperm whales are matriarchal. They live in tight social units, mothers, aunts, sisters, and grandmothers, all invested in raising the group's young collectively, rather than each female fending for her own calf alone. When a pod of orcas targets a group with vulnerable young in it, the adult females execute something researchers call the Margarite formation, or sometimes the rosette or daisy formation, depending on which paper you're reading. The adults arrange themselves into a tight circle, heads pointed inward toward the calves at the center, tails facing outward toward the threat. Then, as the orcas close in, the adults begin thrashing those tails with real force, turning the outer edge of that circle into something closer to a spinning wall of blunt, high-mass impact than a passive shield. A direct hit from a sperm whale's tail carries enough force to stun or seriously injure an orca outright. Trying to punch through that formation to reach a calf isn't a targeted attack anymore. It's running a gauntlet, and the odds of coming out of it unhurt are not in the orca's favor. Now, here's the piece. Almost none of the videos covering this topic actually get into, and it's arguably the single most interesting weapon in the sperm whale's entire toolkit. Sound. Sperm whales are the loudest animals on Earth. Full stop. Louder than any other creature that has ever been measured, land or sea. Their echolocation clicks, generated by forcing air through structures called phonic lips inside that same oversized head, have been recorded at intensities approaching 230 to 250 decibels underwater at the source. For context, a jet engine at takeoff sits somewhere around 140 decibels in air. Underwater decibel measurements don't translate directly to airborne ones because water is a denser medium and the reference pressures used in the measurement scale are different. So a direct one-to-one comparison isn't scientifically accurate, but even accounting for that, the raw acoustic energy a sperm whale can generate is staggering by any standard. And it's not just for show. Researchers studying how sperm whales hunt giant squid in total darkness, thousands of meters down, have proposed that these clicks may do more than simply echo back a picture of the environment. At close range, Some scientists suspect the sheer intensity of the sound itself may stun or disorient squid, effectively softening up prey before the whale ever gets close enough to bite. This particular idea remains actively debated in the marine biology community rather than settled fact, and it hasn't been definitively proven in controlled conditions, which is worth being upfront about rather than presenting it as certainty. What is far better supported, though, and directly relevant here, is that a sperm whale's echolocation and an orca's echolocation work through fundamentally similar biological hardware. Both species rely on a fatty structure in the head called the melon to focus and direct clicks, and both use returning echoes to build a picture of their surroundings. If one animal is capable of producing sound at an intensity that dwarfs anything the other can generate, there's a real biologically grounded case that a sperm whale at close range could, at minimum, temporarily overwhelm or interfere with an orca's own acoustic sense in the middle of a hunt, even without any deliberate weaponization. An animal that suddenly can't read its environment acoustically, mid-attack, in three-dimensional open water, is an animal that has just lost one of its primary hunting tools at the worst possible moment. Whether sperm whales use this actively and intentionally as an offensive tactic against orcas specifically is still an open scientific question, not a confirmed fact. And any documentary that tells you otherwise with total confidence is overstating what we currently know. But the raw acoustic capability is real, it's documented, it's measured, and it's one more variable an orcapod has to weigh before committing to an attack on an animal that can, in theory, scramble their own senses simply by being close enough to click. So far, everything we've covered applies mainly to a sperm whale that has its family group around it, a wall of tails, and a defensive formation. What happens if one gets caught alone? This is where the ocean's vertical dimension becomes the sperm whale's best friend. Orcas are functionally surface zone predators. Their entire physiology, speed, agility, hunting behavior is built around operating in the upper few hundred meters of ocean. And they are, like all cetaceans, air-breathing mammals with a hard limit on how long they can hold a breath, typically only a handful of minutes at a stretch. Orcas rarely dive much beyond a few hundred meters, and pushing past that starts to genuinely strain their physiology. Sperm whales are the deep diving champions of the marine mammal world. They routinely descend somewhere between 1,000 and 2,000 meters, sometimes deeper, hunting giant squid in complete darkness under crushing pressure for as long as 90 minutes at a stretch on a single breath. Their bodies are purpose-built for this. Collapsible rib cages, specially adapted blood chemistry that stores and releases oxygen differently than a surface-dwelling mammal's does, and a tolerance for pressure that would be lethal to almost anything else that breathes air. So when a lone sperm whale, separated from its pod and lacking the protection of the defensive formation, gets targeted by orcas, its final option is simply to dive straight down past the point where an orca can safely follow. The pursuing pod hits a hard physiological wall within a few hundred meters. Continue past that point, and they're gambling with their own oxygen reserves in a way that could genuinely kill them. A sperm whale can hold its breath somewhere on the order of 5 to 10 times longer than an orca can. Past a certain depth, in the dark, an orca simply loses visual and often acoustic contact entirely. There's no clever hunting tactic that solves this problem, because it isn't a tactical problem, it's a hard physical limit. If your prey can survive in a zone where your own body starts shutting down, that prey is, for all practical purposes, untouchable the moment it commits to the dive. Everything up to this point has been about female sperm whales and their young, the matriarchal pods that make up most of the population most people encounter, and most documentaries film. But there's a second category of sperm whale that makes the entire equation even more lopsided, and it involves the adult males. Sperm whales display extreme sexual size dimorphism, meaning males and females essentially occupy different weight classes entirely. A mature female sperm whale, as we covered, tops out somewhere around 30 to 50 tons. A fully mature bull can weigh 60 to 70 tons or more, stretching past 60 feet in length, nearly triple the mass of a female, and comfortably outweighing an entire small pod of orcas combined. And unlike the females, adult bulls typically live alone, wandering vast solitary ranges rather than staying with a matriarchal group. No daisy formation, no protective pod. Just one enormous, heavily armed animal by itself in open water. You'd think a lone target without a defensive formation around it would be the easiest kind of sperm whale to attack. It's the opposite. There are no verified documented cases of orcas ever successfully killing a healthy adult male sperm whale. None. The math simply doesn't work in the orca's favor at that scale. And orcas, being the calculating hunters that they are, appear to understand that instinctively or through learned experience passed down within their own pods, the same way sperm whales pass down defensive behaviors within theirs. Now, it would be inaccurate and a little misleading to leave you with the impression that orcas categorically never engage sperm whales under any circumstances, because that's not quite true, and it's worth being straight about the exceptions rather than overstating the avoidance for dramatic effect. There are genuine, documented cases of orcas successfully killing sperm whales, but virtually every one of them involves the same specific set of conditions. A calf that has become separated from its pod's protective formation, an individual that is already severely injured or sick, or, in the rarest and most extreme documented cases, a full pod of orcas merging with other pods into a superpod of 30 or more individuals, specifically to take on a weakened adult, an effort that can still take hours and result in real injuries on the orca's side. These are not routine hunts. They are opportunistic, high-effort, situational events that happen when the normal defenses, the formation, the depth, the size, have already broken down for some other reason. Healthy, well-defended sperm whales in a group or as a solitary bull are functionally off the menu under ordinary circumstances. Even when an attack does happen and orcas do land bites, there's another anatomical detail working heavily in the sperm whale's favor: blubber. Sperm whales carry a layer of blubber that can run up to 14 inches thick across much of their body, dense, rubbery, and extremely resistant to penetration. An orca's teeth, for all their bite force, which is genuinely formidable, run only around 4 inches long. Do the simple subtraction. A 4-inch tooth against 14 inches of dense fat and connective tissue physically cannot reach any major blood vessel or vital organ underneath. Every bite an orca lands essentially stops in the blubber layer. To actually kill a sperm whale through bites alone, the only viable strategy is a grinding, exhausting war of attrition. Dozens or even hundreds of individual wounds accumulating over hours, sometimes longer, with the sperm whale actively fighting back, thrashing, diving, and potentially ramming the entire time. It is, from a pure energy economic standpoint, an enormously expensive way to get a meal, and orcas, again, are constantly running that cost-benefit calculation in the background of every hunting decision they make. The Essex wasn't an isolated incident either, even if it's the most famous one. And looking at the broader historical record from the era of commercial whaling makes it clear that 18th and 19th century sailors treated aggressive, retaliatory sperm whale behavior as a known, documented occupational hazard rather than a freak occurrence. Whaling logs from the period, kept meticulously by ship captains tracking catches and losses, record numerous instances of bull sperm whales turning on the small wooden whaleboats sent out to harpoon them, capsizing crews, splintering holes with their jaws or their heads, and in some cases pursuing and attacking a ship itself in what surviving crew members described as deliberate, targeted retaliation rather than random thrashing. One particularly well-documented individual, a large pale-coloured bull nicknamed by whalers for his aggressive, ship-attacking behavior off the coast of Chile in the early 19th century was independently reported by multiple separate whaling crews over a period of years, each encounter describing an animal that appeared to actively seek out and engage vessels rather than simply flee an approaching harpoon boat, the way most hunted whales did. Accounts like this are part of why 19th century whalers, men who spent their entire working lives hunting these animals and had every financial incentive to underplay the danger, nonetheless developed a specific, distinct wariness around sperm whales that they didn't extend to baleen species. Blue whales, right whales, and humpbacks were hunted using broadly similar techniques with broadly similar risk profiles. Sperm whales required different tactics, more caution, and carried a meaningfully higher rate of boats lost or crew injured during the hunt itself. A pattern reflected clearly in the whaling industry's own internal records and insurance considerations at the time. When the animals doing the hunting in that era, professional whalers operating with harpoons, boats, and later explosive lancers, treated a species as uniquely dangerous to engage directly. That's a strong independent data point sitting entirely outside modern orca research. And it lines up precisely with everything we now understand about the sperm whale's anatomical and behavioral defenses. It's also worth understanding just how differently a sperm whale reacts to a threat compared to almost every other large whale species commercial whalers hunted, because the contrast tells you something real about the animal's underlying psychology, not just its physical toughness. Baleen whales, blue whales, fin whales, humpbacks overwhelmingly responded to an approaching whaleboat with flight. Exactly the same behavioral pattern orcas exploit today. Sperm whales, particularly bulls, were documented far more frequently standing their ground, circling back toward pursuing boats, or in the more extreme and better documented cases, actively closing distance and attacking. Some naturalists studying whaling records in the decades since have proposed that repeated generational exposure to aggressive human hunting may have reinforced or even sharpened this retaliatory tendency across sperm whale populations during the peak whaling era. Though that specific claim about behavioral change over time remains difficult to verify given the limited data available from before large-scale whaling began. What isn't in question is the base pattern itself, clearly recorded across dozens of independent ships and crews over more than a century of first-hand encounters. Long before modern marine biology ever formalized the same observation using drone footage and satellite tags, the animal orcas are choosing not to fight today is the same animal 19th century sailors, operating with none of our current scientific framework, had already independently concluded was worth extra caution and a different hunting approach entirely. Compare that return on investment to a great white shark, or a seal, or even a blue whale, none of which can hurt an orca back in any meaningful way during the hunt itself. A blue whale's only defense is speed it can't sustain forever. A great white has no coordinated group defense whatsoever and simply flees the area entirely for months once it detects orca presence nearby. Neither of those prey species can break an orca's ribs, disorient its senses, or disappear into a pressure zone the orca's body can't survive. Sperm whales, uniquely among everything orcas are physically capable of overpowering by size and strength alone, can genuinely fight back. On multiple fronts, using multiple independent defensive systems simultaneously. That combination is what actually explains the avoidance. And it's a far more interesting answer than simple size ever could have been. To understand why sperm whales ended up this comprehensively armored against a threat they mostly managed to avoid engaging directly, you actually have to look further back than the orca's own evolutionary history. Because orcas, in the grand timeline of ocean predators, are relatively recent arrivals. The lineage that eventually became the modern sperm whale stretches back millions of years further, into an era populated by predators that made a modern orcapod look almost tame by comparison. During the Miocene epoch, roughly 5 to 20 million years ago, the ancestors of today's sperm whales shared their ocean with Megalodon, the largest predatory shark that has ever existed, reaching estimated lengths of 50 to 60 feet and weights potentially exceeding 50 or 60 tons. They also shared those waters with an animal called Livyatan melvillei, a genuine ancestral relative of the sperm whale lineage itself, but one that had evolved in the opposite behavioral direction, becoming an active apex predator specifically built to hunt other large whales. Armed with teeth measured at nearly a foot long, among the largest functional teeth ever recorded in any animal, living or extinct. Modern sperm whales inherited the defensive architecture, the dense skull, the thick armored blubber, the deep physiological toughness from ancestors that had to survive routine encounters with predators genuinely capable of killing and eating something the size of a whale. An orcapod, by comparison, even a large and coordinated one, is working with a fraction of the raw threat those ancient sperm whale ancestors evolved to withstand. The modern sperm whale isn't over-engineered for the orca specifically. It's simply carrying forward defenses, built for a far more violent ocean that existed millions of years before orcas ever showed up as a serious predatory force at all. It's worth pausing here to be fair to orcas too, because none of this should be read as orcas being somehow weak or overhyped. They remain, by any reasonable measure, the single most versatile apex predator in the ocean today, capable of taking down almost every other species that swims, coordinating multi-hour hunts with military-grade precision, communicating through pod-specific dialects, and passing down entire cultural hunting traditions across generations. Something almost no other predator on the planet does at this level of sophistication. The point isn't that orcas are somehow overrated. The point is that intelligence this refined comes paired with genuine caution, and a truly intelligent predator doesn't waste effort or risk injury chasing a fight it can't reliably win, no matter how capable it is in every other context. Recognizing a bad trade isn't weakness. It's precisely the kind of calculated restraint that makes an animal this dangerous in the first place. So when you put the entire picture together, the sperm whale isn't surviving because it's bigger. Because on a pure numbers basis, it usually isn't. Not compared to prey orcas already routinely take down. It survives because it broke the fundamental rule almost every other whale species in the ocean follows instinctively. It doesn't run. It stands still, turns to face the threat directly, and forces its attacker to reckon with a dense, potentially weaponized skull, a coordinated defensive formation backed by tails capable of genuinely serious injury, an acoustic system that may scramble the very sense its predator depends on most, and an escape route straight down into a pressure zone that could kill the pursuer outright if it tries to follow. Stack 4 independent defensive systems on top of each other. Systems that, unlike a blue whale's single strategy sprint, don't all collapse the moment one of them fails. And you get an animal that isn't simply too big to bother with. You get an animal that is, from every practical angle an orcapod has to weigh before committing, genuinely too expensive and too dangerous to be worth the fight, except in the rare moments when its defenses have already been broken by something else entirely. That's not a fear born of size. That's the kind of caution that only exists between two predators, intelligent enough to actually calculate the odds before the fight even begins, and smart enough, most of the time, to walk away from a trade that isn't worth making. To really understand how deliberate that calculation is, it helps to look at how orcas behave when the math actually does favor them, because the contrast is striking. Off the coast of Western Australia, near Bremer Bay, researchers have documented orcapods hunting blue whales using a specific, repeatable strategy that shows exactly how methodical these animals are when they've decided a hunt is worth the risk. The pod doesn't simply swarm the whale, they target the blowhole first, taking turns biting and physically pushing the whale's head beneath the surface, denying it the ability to breathe, while a second group works the tail and pectoral fins to slow its swimming and limit its ability to maneuver. It's a division of labor, executed by animals that have never been trained to do this by anyone, coordinating in real time, adjusting their positions based on how the whale reacts. A hunt like this can run over an hour, sometimes considerably longer, with the whale thrashing violently, letting out desperate, explosive breaths whenever it briefly manages to surface. By the end, the animal is covered in open wounds, utterly exhausted, and finally succumbs, not to any single killing blow, but to the cumulative effect of the entire coordinated effort. Immediately afterward, the pod doesn't simply feed in silence. Researchers have observed celebratory behavior, tail slaps, breaching, an apparent burst of excitement among the group, which several scientists interpret as a social response to a difficult, successful hunt rather than pure feeding behavior. This is what orcas look like when they've correctly judged that a fight is winnable. It's precise, coordinated, and confident. Compare that energy and commitment to how the same species behaves around a healthy adult sperm whale. Cautious, distant, watching rather than engaging, and the difference in behavior alone tells you everything about how orcas are actually assessing the two animals. The same pattern of calculated risk assessment shows up again when you look at how orcas hunt seals along the Antarctic ice shelf. A completely different environment and a completely different prey animal, but the same underlying decision-making process. A Weddell seal hauled out on a floating ice floe is, on the surface, an easy target. Small, slow on land, seemingly trapped. But orcas don't simply climb up after it because they can't, and because doing so would strand them uselessly out of the water. Instead, the pod lines up in formation, sometimes as far as 50 meters back from the floe, and swims in unison directly at it, diving and rolling together at the last possible moment like a coordinated wave machine. The resulting swell floods across the ice, destabilizing it, and the pod repeats the maneuver again and again until the floe tips and the seal is forced into the water. On average, this entire process takes somewhere around 30 to 40 minutes of repeated, deliberate effort. It's a technique that has to be taught, not simply performed on instinct. Researchers studying orca populations that use this tactic have observed mothers deliberately practicing the maneuver alongside their young for years before those young ever attempt to catch live prey themselves. Sometimes introducing props like loose kelp into the training sessions to add complexity. Some calves never fully master it. The disorienting sensation of briefly grounding an enormous body out of the water is apparently unsettling enough that certain individuals simply never attempt a live hunt using the technique, regardless of how many practice sessions they go through. The ones that do master it typically need years of guided repetition first, and even then, their first live attempt usually still requires an adult's direct assistance to get back into open water safely afterward. That is an extraordinary amount of investment for a single hunting technique, and it underlines something important about how orcas actually operate. Nothing here is simple predatory instinct firing on autopilot. Every technique, every judgment call, every decision to engage or hold back is the product of a learning process that spans years and multiple generations. That same extended generational learning process is also precisely why the evidence we have of sperm whales fighting back against attackers isn't limited to orca encounters at all. And looking at how sperm whales fare against a completely different kind of predator only reinforces how seriously their defenses should be taken. Marine biologists studying wild sperm whale populations have spent decades photographing and cataloguing the skin around these animals' heads and lower jaws, and what they consistently find are circular sucker mark scars, sometimes overlapping in dense clusters left behind by the tentacles of giant and colossal squid encountered during deep dives. Some of these scars measure several inches across, evidence of prey that fought violently before losing. A sperm whale's entire deep diving lifestyle revolves around descending into total darkness at crushing pressure and physically wrestling multi-hundred-pound cephalopods, animals equipped with their own sharp, rotating sucker rings, and, in some documented cases, hooks along their tentacles, specifically evolved to injure exactly this kind of predator. Sperm whales carry the physical evidence of these encounters their entire lives, and the sheer density of scarring found on many individuals suggests these are not occasional skirmishes, but a routine, repeated part of how this species survives and feeds. An animal that spends a meaningful portion of its adult life engaged in close quarters combat against armed prey in total darkness 1,000 meters underwater is not, by any reasonable definition, a passive or defenseless creature on the surface either. The same physical toughness, the same willingness to absorb damage and keep fighting, that lets a sperm whale survive routine battles with giant squid in the abyss is exactly the toughness that makes it such an unappealing target for a pod of orcas weighing whether a surface confrontation is worth the risk. But here's the detail that matters most for understanding orca decision making. Researchers have documented cases where a wave washing pod approaches a flow, realizes partway through that the animal on it is the wrong species, and simply stops and swims away without ever completing the hunt. These orcas are shockingly selective eaters, willing to abandon significant invested effort the moment the calculation stops making sense. If an orca pod will walk away from a nearly completed hunt over something as simple as targeting the wrong species of seal, it becomes far easier to understand why an entire pod would decline to engage a 50-ton animal that can break ribs, disorient their senses, and vanish into water they physically cannot follow it into. This selectivity connects to something else worth understanding about how orcas learn what to hunt and what to avoid in the first place, because none of this behavior is instinctive in the way a shark's hunting pattern is instinctive. Orca populations are divided into what researchers call ecotypes, distinct cultural groups that can occupy the exact same stretch of ocean for generations without ever hunting the same prey, or even communicating in a way the other group would understand. Resident orca populations in the Pacific Northwest, for example, feed almost exclusively on Chinook salmon, identifying the specific species by the acoustic signature its swim bladder produces, and will swim directly past far more abundant salmon species without showing any interest at all, simply because no calf in that population has ever been taught that other salmon species count as food. Transient orcas, occupying the same general waters, hunt marine mammals instead: seals, sea lions, and occasionally other whales, using almost total acoustic silence to avoid alerting prey that can hear echolocation clicks coming. These two populations don't interbreed, don't share hunting techniques, and in some study cases show genetic divergence significant enough that some researchers argue they may already function as functionally separate species, despite living in overlapping territory. Every one of these highly specific hunting behaviors, what to eat, how to catch it, when a fight is worth having, gets passed down maternally, calf to calf, generation to generation, the same way sperm whales pass down their defensive formation training to their own young. If an orca population somewhere along its history learned through direct experience that adult sperm whales are a costly, dangerous, low return target, that lesson would get encoded into the group's behavior and taught forward exactly the same way Chinook salmon preference gets taught forward, not through instinct, but through observed, transmitted culture. And there's real reason to believe that kind of transmitted caution exists, because orca society leans heavily on exactly the kind of accumulated experience that would preserve a lesson like that across decades. Female orcas are among only a small handful of species on the planet known to go through menopause, ceasing reproduction around age 40 while continuing to live for decades afterward, sometimes past 90 years old in the wild. In most animal species, individuals that stop reproducing don't survive much longer, because evolution has little use for them once their genes stop being passed on directly. Orcas are a striking exception, and researchers studying pods led by older post-reproductive females have found something remarkable. Those pods show significantly higher survival rates during periods of food scarcity, driven almost entirely by the older females' accumulated knowledge of migration routes, seasonal prey patterns, and presumably which hunts are and aren't worth attempting. When a pod's oldest matriarch dies, researchers have documented measurable increases in mortality among her surviving family members in the following years, particularly calves. These grandmothers function as living repositories of decades of hard-won experience, and it stands to reason that an experience as costly and memorable as a failed or narrowly successful encounter with an adult sperm whale would be exactly the kind of lesson that gets carried forward and taught to the next generation, reinforcing the same caution generation after generation without any single orca needing to personally relearn it the hard way. None of this diminishes what makes orcas remarkable, and it's worth being clear about that before wrapping up, because the story here isn't really about a weakness in an otherwise dominant predator. It's about what real, adaptable intelligence actually looks like in the wild, applied consistently across every single decision an orca pod makes, not just the ones that end in a kill. The same calculating mind that identifies a blue whale's exploitable weakness, commits fully to an hour-long coordinated hunt, and celebrates the result, is the same mind that looks at an adult sperm whale, runs a different calculation, and quietly decides the reward isn't worth the risk. That's not timidity. That's the exact same predatory intelligence pointed at a different outcome. And on the other side of that equation, an animal that abandoned the instinct to run armored itself across 4 completely independent defensive systems over millions of years of surviving worse predators than any orca alive today, and now stands its ground against the single most capable hunter in the modern ocean, and mostly wins that standoff simply by never starting the fight at all.